So in this video, I'll cover about the multi-stage graph problem, which can be solved using the dynamic programming concept. So coming to the dynamic programming, what is actually the dynamic programming? That is, dynamic programming is an algorithm design technique for optimization problems. So there are various kinds of the strategies which are being involved to solve a particular problem using the algorithms. The strategies, which includes the divide and conquer strategy, the greedy approach, the dynamic programming, backtracking, branch and bound. So there are certain kind of these strategies which can be solved using these kinds of the algorithms. So coming to the dynamic programming, so in this kind of the dynamic programming, it is the result of the solutions of the certain stages. Like take for example, if you consider the multi-stage graph problem, within the multi-stage graph problem, given certain kind of the graph and identify the various kinds of these stages, and at each stage, you'll be finding what is the optimal solution that can be reached to the respective vertex at the various stages. That is, if you find a solution, that is optimal solution from S to the stage 4, which also includes it is an optimal solution from S to stage 1 to stage 2 to stage 3 and as well as the stage 4. So it is dynamic programming. It is also quite similar to the divide and conquer in such a way that this kind of the main problem is being divided into sub-problems. But when concerned the difference between the dynamic programming and the divide and conquer, unlike in the case of the divide and conquer, you will be splitting this kind of the main problem into the sub-problems, and where each kind of the sub-problem is being treated independently and it is being solved. But unlike in the case of the dynamic programming, each problem, it is not independent. The result, that is the solution of this kind of the sub-problem, can be utilized to solve a certain kind of the problem in solving the main problem. So unlike in the case of the divide and conquer, sub-problems are not independent, and sub-problems may share the solutions of these kinds of the sub-problems to find the solution of any kind of the sub-problem in order to solve the main problem. And however, the solution to one subproblem may not affect the solutions to other subproblems of the same problem. And dynamic programming reduces the computation. That is, in some scenarios to solve a particular problem, it may take the exponential time. And using this kind of the dynamic programming, we can reduce that kind of the exponential time in the polynomial time. This is the best example that can be given related to the dynamic programming. That is to solve the problem of Fibonacci series. That is Fibonacci series, which is being given by the formula. That is Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. Consider you need to solve the Fibonacci of 5. So this kind of the problem is being divided into two subproblems. That is Fibonacci of 4 and similarly Fibonacci of 3. And further, once again, this is recursively called to the functions like Fibonacci of 3 and similarly Fibonacci of 2 and so on. So at the lowest level, you can find Fibonacci of 1 and similarly Fibonacci of 0. We have found out this kind of the solutions. That is Fibonacci of 1 and similarly Fibonacci of 2. So once you have found the solution to these subproblems, that is Fibonacci of 1 and similarly Fibonacci of 0, then whenever you need to find the solution to the Fibonacci of 2, then Fibonacci of 2 is being given by the formula, that is Fibonacci of n equal to Fibonacci of n minus 1 plus Fibonacci of n minus 2. That indicates Fibonacci of 2 can be identified or can be solved using Fibonacci of 1 plus Fibonacci of 0. That is, at this particular stage, that is whenever you need to find Fibonacci of 2, you don't have to once again compute what is this Fibonacci of 1 and what is this Fibonacci of 0, because already we have found the solution for Fibonacci of 1 and Fibonacci of 0. In this fashion, at every level, like for example, Fibonacci of 3. So whenever you need to find the solution for the Fibonacci of 3, which has been given by the formula Fibonacci of 2 plus Fibonacci of 1. So already we have computed what is this Fibonacci of 2 and similarly Fibonacci of 1. So whenever you need to find Fibonacci of 3, you don't have to once again recompute what is the solution for a Fibonacci of 3. And that is what the dynamic programming concept is being involved. So at every stage, you'll be finding what is the optimal solution. And once you have found the optimal solution at the subproblem level, and these optimal solutions can lead to the solution to your main problem in the dynamic programming concept. And the various problems that can be solved using the dynamic programming, the applications which involves, like we can solve the multi-stage graph problem, and we can solve the all pairs shortest path problem, and similarly we can solve the traveling salesperson 0 or 1 knapsack. Unlike there are 2 knapsacks which we have covered, that is in the knapsack, that is using the greedy approach, which is called as fractional knapsack. And unlike in the case of the dynamic programming, it is 0 or 1 knapsack. That is, you can take the entire item or you need to drop the entire item. But unlike in the case of the fractional knapsack, which has been solved using the greedy approach, you can take the fractions, the portion of that kind of the item. The item can be broken in the greedy approach. But unlike in the dynamic programming, you cannot break this kind of the item into the portions. And coming to the multi-stage graph problem. So here there are certain inputs which are being given for the multi-stage graph problem, and similarly the goal is also being identified. That is, given certain kind of the graph which contains set of vertices and set of edges, and this kind of the graph has to be partitioned into k greater than or equal to 2 disjoint sets vi, and where I ranges between 1 to k. That is, given certain kind of the graph, and this graph has to be split into the stages, where k indicates the stages. And how to identify the stage, that will be discussed in this next continuation. So if u comma v is an edge in the E, then u belongs to the vi, that is at stage, some kind of the stage, and v belongs to vi plus 1, that is at the next stage. There is an edge from stage 1 to stage 2, where u belongs to the stage 1, assume, and something like your v belongs to the next stage. And there are assumptions which are being given in the multi-stage graph, that is c of I comma j be the cost of edge I comma j, and the cost of the path from the source to the sink, that is a target, sum of the cost of the edges on the path. So what is actually the problem of the multi-stage graph, and what is the goal is, the goal of the multi-stage graph problem is to find the minimum cost from source to the destination vertex. And there is also another assumption, there is only one source vertex and there is only one destination vertex in the multi-stage graph problem. So every path starts at S and goes through the stage 1, stage 2 and so on till the last stage. And there are 2 approaches which are involved in the multi-stage, that is forward approach and as well as the backward approach. So within the case of the forward approach, there are 2 parameters which have to consider, that is cost and as well as path. So in the forward approach, we assume that there are k stages in the graph. What is the stage? That will be discussed in your next slide. So either if you take the forward approach or if you take the backward approach, there are certain stages which are being denoted by, the k. And whenever you need to find the cost in the forward approach, start from the last stage and find out the cost of each and every vertex in the graph until you reach to the first stage. But whereas the path, that is to find the minimum cost path, it is from the source to the destination. So here in the forward approach, cost is being calculated from the last stage until you reach to the first stage. But whereas the path, that is from the source to the destination. This is what you need to understand regarding the forward approach. And unlike in the case of the backward approach, the backward approach is quite opposite of this one. That is that will be discussed in the next slide, because you need to also find there is a formula involved. Cost of I comma j equal to C of j comma L plus cost of I plus 1 comma L, where L belongs to the Vi plus 1 and j comma L belongs to the edge, that is E. And within the case of the backward approach, there are case stages which are being assumed, and the cost and as well as the path, the same thing which I have said in the previous part, that is forward approach. Unlike in the case of here the forward approach, the cost we need to find from destination last stage to the first stage, but whereas path from the source to the destination, that is regarding the forward approach. And coming to the backward approach, the cost is being calculated, that is here you can observe find the each and every vertex starting from the first stage up to the kth stage. Starting from the first stage to the last stage, you will be finding the cost. And how to find the cost? Here the cost has been given in your backward approach, that is b cost of I comma j equal to min of b cost of I minus 1 comma L plus C of L comma j. And whereas the path, that is minimum cost path from destination to the source, that is what the backward approach has been involved. And consider certain kind of here the given graph. So the graph has been given and you can assume how many number of vertices are present, that is n equal to 12, and k, that is there are 5 stages, and the source is the vertex 1 and the destination is vertex 2, 12. So here what do you mean by the stage? So stage is nothing but, you can just assume it is an horizontal line, vertical line that has been drawn. That is, this is your stage 1 with vertex 1, stage 2 containing the vertices, that is 2, 3, 4, 5, and similarly stage 3 containing the vertices 6, 7, 8, and so on. So there are totally 5 stages starting from the source vertex till the destination vertex. And how to solve the problem of multi-stage graph problem using the forward approach? This is related to the forward approach. So forward approach, which has been given by the in order to identify the cost of I comma j, that is min of C of j comma L plus cost of I plus 1 comma L. So you need to be aware about what is this I, what is this j, and what is this L, and so on. So considering about the cost of I comma j, what does this I indicates? So I indicates the stage. According to the given graph, there are 5 stages ranging from stage 1 to the stage 5. And the j indicates the vertices that are present at stage I. This means, like take for example, I value is equal to 2. It indicates it is a stage, that is at stage 2. What are the vertices which are present? So the vertices which are present at stage 2 are, that is vertex 2, 3, 4, and similarly 5. That is how you need to understand about cost of I comma j, that is what is this I, and similarly what is the j. Similarly, if you need to if you consider I value to be equal to 4, that is, it indicates it is the stage. At stage 4, what are the vertices? That is, we have the 9, 10, and similarly 11. So these values becomes the j. That is, when the value of your I is equal to 4 in the equation, that is cost of I comma j, that is I is equal to 4, consider. Then in such case, this indicates the stage. I is equal to 4, that is a stage. And j value becomes, what is j value indicates? Vertices that are present at stage I. So at stage 4, the vertices which are present are, that is 9, 10, and similarly 11. So these are the values of j when you consider the I to be equal to 4. These are the stages. And the next one, that is C of j comma L. So what does j indicates and what does L indicates? So j indicates the vertex present at stage I, and L indicates the vertex connected from j. Consider, that is 2 is the value of j. So consider j value is equal to 2 according to this kind of C of j comma L. So j indicates the vertex that is present at stage I, and similarly here we are considering the j value to be equal to 2. From 2, what are the various edges which are being connected? That is, from 2 we can reach to 6, and from 2 we can reach to 7, and from 2 we can reach to 8. So here the L values become 6, 7 and similarly 8. So L value will be equal to 6, L value will be equal to 7 and L value will be equal to 8 when you consider C of j comma L. And coming to solving this kind of the problem, that is multi-stage graph problem using the forward approach. So within the case of the forward approach, it has been given by the formula to compute the cost, that is cost of I comma j equal to min of C of j comma L plus cost of I plus 1 comma L. As I mentioned, to find the cost, that is, there are two approaches involved in a multi-stage graph problem, that is forward approach and as well as the backward approach. In the forward approach, the cost is computed in the reverse order. That is, cost is being computed from the last stage to the first stage. And the path is the forward. That is, the path can be identified. That is, minimum cost path can be identified from the source vertex over to the destination vertex. And when you consider the backward approach, the cost is being computed in the reverse order. That is, from the first stage to the last stage. And whereas the path can be identified in the same fashion, that is backward. That is from the destination vertex to the source vertex. So when coming to the forward approach, and when you need to calculate the cost, it is from the last stage to the first stage. So you need to consider the last stage, that is stage 5. So at stage 5, what does this value of I indicates? So I indicates the stage. So here I value becomes 5 and the j value. What does the j value indicates? At stage 5, what are the vertices, or what are the vertices which are being present? Since there is only one vertex, that is, you need to compute cost of 5 comma 12, and it has been assumed that is cost of the last, it is an initial condition which has been used, that is cost of 5 comma 12 will be equal to 0. Take any kind of the given graph, that is cost of the last stage comma the vertex, the destination vertex that is present is being initialized with the value to be equal to 0, and come to the next stage. That is, the next stage is of the stage 4. So you need to find the stage 4, cost of stage 4. That is, here according to this kind of the formula which is being given by cost of I comma j. So at the stage 4, so here I value will be equal to 4. That is, I value will be equal to 4. At stage 4, what are the vertices which are present? So the vertices are 9, 10, 11. And that is the purpose where you need to find cost of 4 comma 9, cost of 4 comma 10, and similarly cost of 4 comma 11. So these are the cost which has to be identified at stage 4. So how to find the cost of 4 comma 9? Just replace the values of your j, l respectively. So according to the formula, min of C of j comma L plus cost of I plus 1 comma L. So what does this j indicates? J indicates the respective vertex that is being present at stage 4, that is 9. So C of 9 comma from 9, what are the edges which are being connected? That is, from 9 we can connect to the vertex that is 12. That is what the 12 is being indicated. Plus cost of I plus 1, I indicates the stage. And according to computing cost of 4 comma 9, that is 4 is the stage I value. So 4 plus 1, that will be equal to 5, and the value, that is the value of the L. L indicates the edge that is being connected at that stage and at the respective vertex. From 9 it is 12, so 9 becomes the value of the j, and similarly the L value becomes the 12. So 5 comma 12, stage indicates, I plus 1 indicates the stage. 4 plus 1, that is 5 comma 12. So already we have computed cost of 5 comma 12 is equal to 0, plus and cost C of 9 to 12, that is edge cost. 9 to 12 edge cost is being provided by, that is 4, and that is what we can observe the cost of 4 comma 9. So cost of 4 comma 9 is equal to, that is 4, that is 4 plus 0, that will be equal to 4. And also you need to compute the next one, that is cost of 10 comma 4 comma 10. So cost of 4 comma 10 equal to, that is replace the values of your j and l, that is j value is equal to 10 and from j, that is from 10 we can connect to 12, that is an edge, plus cost of I plus 1, that is 5 comma l value becomes that 12. So here 2 plus 0, that is c of 10 comma 12. So from 10 to 12 the edge cost is being provided, that is 2, plus cost of 5 comma 12, already we have taken cost of 5 comma 12 is equal to 0. In the similar fashion, find cost of 4 comma 11, that is c of 11 comma 12 plus cost of 5 comma 12, that will be equal to 6 plus 0, that is 6. So far we have covered about stage 5 and similarly stage 3, and this process has to be completed for until you reach to the first stage, that is you need to complete stage 3, that is you need to calculate the stage 3. So within the case of your the stage 3, that is given the formula cost of I comma j. So cost of I value indicates the stage, we are at stage 3. So at the stage 3, what are the vertices which are being present? So the vertices which are present at stage 3 are 6, 7 and 8. So these are the cost values which are to be found at stage 3. So which has been given by the formula. That is, if you consider stage 3 and the value of your the j to be equal to 6. So from 6, identify what are the various edges which are being connected. That is, from 6 we can connect to 9, and from 6 we can connect to 10. So these are the L values, and whereas this is your j value, and that is how, that is c of 6 comma 9, and similarly c of 6 comma 10 is being used. And according to the formula, plus cost of I plus 1, that is we are at stage 3, that is cost of 4 comma L value provided in the equation itself, that is 9 comma c of 6 comma 10 plus cost of I plus 1 comma L. So here what is c of 6 to 9, that is 6 to 9 is equal to 6 plus cost of 4 comma 9. So already we have calculated cost of 4 comma 9, that will be equal to 4. In the similar fashion, that is c of 6 comma 10 is equal to 5, cost of 4 comma 10 will be equal to 2, and minimum between 6 plus 4 and 5 plus 2, that will be equal to 7. And in the next step, you have to identify, or you need to calculate cost of 3 comma 7. So from 7, what are the various edges which are being connected? Those becomes the values of your L. So here you can observe, that is 9, from 7 we can reach to 9, and from 7 we can reach to 10. So two parts will be present, that is c of 7 comma 9 and c of 7 comma 10 plus cost of I plus 1 comma L, that is we are at stage 3, that is 4 to 9, cost of 4 to 9, and similarly cost of 4 comma 10, and you get the values, that is 4 plus 4 plus comma 3 plus 2. Between these two, the minimum will be equal to 5. And the next one, that is cost of 3 comma 8 has to be found. So cost of 3 comma 8, which is given as min of c of 8 comma 10 plus cost of 4 comma 10, that is from 8, that is from 8 we can reach to 10, and from 8 we can reach to that is 11. So there are two parts, c of 8 comma 10 and c of 8 comma 11, and replace the values of your cost of I plus 1 comma L with the respective values, and you get the minimum value to be equal to 7. So far we have identified, we have calculated cost of 5 comma 12 at stage 5, and at your stage 4 we have computed cost of 4 comma 9, cost of 4 comma 10, 4 comma 11, and at stage 3 we have computed cost of 3 comma 6, 3 comma 7, and as well as the 3 comma 8. In the similar fashion, you can also identify the next stage, that is stage 2. So at the stage 2, identify what are the vertices which are present. The vertices which are present are 2, 3, 4, 5. So you have to compute cost of 2 comma 2, cost of 2 comma 3, cost of 2 comma 4, and as well as cost of 2 comma 5. So this is okay, stage 3 is calculated. And the next part is you need to identify at the stage 2. That is at the stage 2, you have to identify cost of 2 comma 2, cost of 2 comma 3, cost of 2 comma 4, and similarly cost of 2 comma 5. And if you consider this is your j value, that is 2, and identify what are the direct edges which are being connected. That is, from 2 we can reach to 6, from 2 we can reach to 7, and from 2 we can reach to 8. And that is how here you can observe C of 2 comma 6, C of 2 comma 7, and similarly C of 2 comma 8 are being used. And similarly, when you consider about the third vertex 3, so from vertex 3 we can reach to 6, we can reach to 7, and that is how we have used C of 3 comma 6 and similarly C of 3 comma 7. Similarly, from 4, so from 4, that is here you can observe there is only one edge that has been connected over to the 8, that is C of 4 comma 8. And when you consider about vertex 5, this is connected to the 7 and connected to the 8. So C of 5 comma 7, C of 5 comma 8, and the remaining values part use the formula plus cost of I plus 1 comma L. And so far here when you consider cost of 2 comma 2, it is a minimum between 4 plus 7 comma 2 plus 5 comma 1 plus 7. The minimum will be equal to 7. Similarly, cost of 2 comma 3, the minimum value will be equal to 9. Cost of 2 comma 4, the minimum value will be equal to 18. Cost of 2 comma 5, the minimum value is equal to 15. So at your stage 2, that is, we have started from stage 5 and identified what is the minimum cost of all the various kinds of the costs that are being associated. So at stage 4, we have identified stage 4, that is, we have computed the cost, and stage 3, we have computed the cost, and the stage 2, we have computed cost of 2, 2, 2, 3, 2, 4, and as well as 2, 5. And the next stage becomes stage 1. So from stage 1, what are the vertices which are being connected? That is, from 1 we can reach to 2, from 1 we can reach to 3, 4, 5. So how many values you need to compute? That is cost of 1 comma 2, cost of 1 comma 3, cost of 1 comma 4, and cost of 1 comma 5 related to the stage 1. So at your stage 1, that is, you need to compute cost of 1 comma 1. So when you consider 1, here you can observe that is, from 1 we can reach to 2, from 1 we can reach to 3, 4, and similarly 5. So there are 5 parts: 1 to 2, 1 to 3, 1 to 4, and similarly 1 to 5. And the remaining values according to the formula plus cost of I plus 1 comma L. And these are the respective values of your cost of 1 comma 1 with the minimum value to be equal to 16. There are two values which are being obtained, that is 16 comma 16 comma 21 comma 17. So here cost is equal to 16. What can you interpret? That is, the minimum cost to reach from the source to the destination is equal to 16. That is what your solution for the multi-stage graph problem. So this is not the complete one, because there are, as I mentioned, there are two parts, that is cost and as well as the path. So cost is been identified, that is with the minimum cost to be equal to 16. And the next part is you need to identify the path. So what is the path which leads to the minimum cost to be equal to 16? So there is a certain kind of the formulas, statements which are being given to identify what is the path according to the algorithm of multi-stage graph problem using the forward approach. That is, P of 1 equal to 1, P of k equal to n, and for j equal to 2 to k minus 1, do P of j equal to d of P of j minus 1. That is a P of 1. We know that what is the source vertex. The source vertex is 1, and there are certain paths which has to be taken to reach to the respective destination. And according to our problem, that is the last vertex, that is present destination vertex, is equal to 12. So here P of 1 equal to 1, that is a source vertex, and P of k equal to n. K indicates the stage. At the stage 5, what is the vertex that is present? That is n. N indicates the number of the vertices. Given in your input, if you consider n equal to 12, there are 12 vertices. So P of 5 is equal to 12 will be the value of your P of k. And the next statement, that is for j equal to 2 to k minus 1, do P of j equal to d of P of j minus 1. So here P of 1 to k is the minimum cost path, and d of I comma j be the value of L where L is a node that minimizes C of j comma L plus cost of I plus 1 comma L. So here we know that what is the source vertex, that is P of 1 equal to 1. And similarly, we also know the destination vertex, that is 12, which is present at the stage 5. And then we need to compute at each stage, that is path 2. So how to identify P of 2? According to the formula which is given, P of j equal to d of P of j minus 1. So here similarly you need to also compute P of 3 and you need to also compute P of 4. So when you consider the stage 2, that is, these are the cost values at the stage 2. So at the stage 2, what is the minimum value? That is, we have the values 7, 9, 18 and similarly 15. This is already been computed in your previous part. And out of these, the minimum is equal to 7. So minimum is equal to 7. And out of this, what is the value of your the j, which negates the vertex? That is 2. That will be the respective value of your the P of 2. In the similar fashion, at your stage 3, that is at the stage 3, identify what is the minimum value. That is, we have the values 7, 5, 7. The minimum will be equal to 5. And out of this, what is the value of your the j, which indicates the vertex? That is 7. Include this within the case of P of 3. So P of 3 will be equal to 7. And within the stage 4, there are 3 values of your cost, that is 4, 2, 5. The minimum will be equal to 2. And what is the respective value of your the j, that is vertex, that is 10. Include the same thing, that is in your P of 4. So P of 4 will be equal to 10. So what can you interpret? That is, the path is equal to 1 to 2 to 7 to 10 to 12. That is the minimum cost, multi-stage graph problem which can be solved. That is, from 1 we can reach to 2, and from 2 we can reach to 7, and from 7 we can reach to 10, and with the total cost to be equal to 16. So there are two parts which have identified. The cost has been identified. What is the minimum cost for the given multi-stage graph problem? According to our problem, that is 16 is the minimum cost, and the path is also been identified. That is P of 1 equal to 1, P of 2 equal to 2, P of 3 equal to 7, P of 4 equal to 10, and P of 5 is equal to 12. That is, start from your source vertex 1 and then reach to the edge, that is 2, that is vertex 2, and from vertex 2 to vertex 7, and from vertex 7 to 10, and as well as 12. And the total cost will be equal to 16. This is how we can solve the problem of multi-stage graph problem using the forward approach.